At the edges of our solar system, where the sun appears as a distant and small disk, temperatures drop to extremely low levels, nearing the absolute cosmic freeze. In this dark and mysterious region, Uranus, the seventh planet from the sun, reigns supreme as a cold and remote gas giant. Surrounded by an aura of fascination and detachment, Uranus lies billions of kilometers from Earth, almost unreachable, a largely unexplored world that hides fascinating secrets. Uranus, characterized by a blue-green atmosphere composed mainly of hydrogen, helium, and methane, is a truly unique planet. Unlike the other gas giants in the solar system, such as Jupiter and Saturn, Uranus is tilted on its side, meaning it rotates almost perpendicularly to the plane of its orbit. This strange orientation causes extreme seasons, with each pole spending 42 years in total darkness followed by 42 years of constant sunlight. However, one of the most intriguing aspects of Uranus is not just its peculiar tilt, but the system of moons that accompany it. Uranus has at least 27 known moons, each offering unique opportunities for scientific research. Among these, one of the smallest and innermost, Miranda, has recently become the focus of scientific attention. Despite its small size, just 470 kilometers in diameter, Miranda may hold secrets capable of changing our understanding of habitability in the solar system. Miranda, small, irregular, and covered in ice, was once considered little more than a frozen and insignificant moon. Its small size and apparent lack of geological activity made it less interesting than its larger neighbors. However, everything changed when NASA's Voyager 2 probe, during its historic flyby in 1986, sent back extraordinary images of Miranda's surface. These images revealed a surprisingly complex and mysterious world, full of faults, ridges, and cracks, indicating a tumultuous geological history. The Voyager images showed that Miranda's surface was crossed by deep faults, some as high as 20 kilometers, taller than the Grand Canyon on Earth. These colossal chasms alternate with vast plateaus and regions that appear shaped by geological catastrophes. But what most fascinated scientists were the coronae, large, dark, polygonal structures, resembling scars, that mark Miranda's surface. These corona, three of which, Arden, Elsinore, and Inverness, have been particularly studied, appear to be remnants of ancient geological phenomena. What created these strange formations? The answer to this question has puzzled scientists for decades. Initially, it was hypothesized that Miranda had suffered catastrophic impacts with other celestial bodies, events that would have left permanent scars on its surface. However, new models suggest that the answer might be much more complex. The coronae might have been caused not by external impacts, but by internal processes within the moon itself. This is where one of the most fascinating theories comes into play. Beneath Miranda's icy crust, there could be an ocean of liquid water. The idea that such a small body, so far from the sun, could host an underground ocean is surprising, but not unprecedented. In recent years, we've discovered that other moons in the solar system, such as Europa and Ganymede, moons of Jupiter, and Enceladus and Titan, moons of Saturn, hide oceans beneath their icy crusts. According to recent studies conducted by researchers at Johns Hopkins University, Miranda might share this same feature. Using advanced simulations based on images collected by Voyager 2, scientists have hypothesized that Miranda's ocean could extend to a depth of 100 kilometers, covered by an ice crust about 30 kilometers thick. This ocean, if it exists, might be kept liquid by a phenomenon called tidal heating. Tidal heating occurs when a moon experiences gravitational forces due to its interaction with the planet it orbits, and sometimes with nearby moons. These forces cause slight deformations in the moon, generating heat through internal friction. In Miranda's case, it seems that its past was marked by an orbital resonance with other moons of Uranus, which would have amplified these tidal forces. This process would have heated Miranda's interior enough to melt some of the ice, creating a liquid ocean beneath the surface. If such an ocean once existed, or still exists, the implications would be extraordinary. On Earth, water is the basis of all known life forms. Isolated aquatic environments, protected by a thick ice crust, could provide a refuge for extremophile life forms capable of surviving in extreme conditions. While the idea of finding life on Miranda is still far from confirmed, The possibility of discovering habitable environments beneath its surface has sparked the interest of scientists worldwide. This discovery would radically change our view of the universe. If a small satellite like Miranda can maintain a liquid ocean, then other similar bodies scattered throughout the solar system could do the same. The idea that icy, distant, and inhospitable worlds on the surface could hide underground oceans offers new perspectives for the search for extraterrestrial life. The hope is that a future mission could explore the Uranus system and gather new data to confirm or refute these hypotheses. Such a mission might take decades to plan and launch, but in the meantime, the data collected by Voyager 2 continues to be a valuable source of information. Nordheim and his team are using every available resource to analyze these images with new technologies and models. Miranda is not just one of many moons of Uranus, but a small world inviting discovery. Exploring what might lie beneath its icy surface is a fascinating journey, pushing us to rethink the limits of our knowledge of the solar system. Thank you for joining us on this cosmic journey. If you enjoyed it, don't forget to leave a like, subscribe to the channel, and activate the bell to not miss the next videos.